Hey everyone, welcome back to the channel. My name is Yaniv Hoffman and today we are diving into a cutting-edge topic, Agentic AI in cybersecurity. So with all due respect to ChatGPT, the future probably belongs to AI agents. And the use of AI agents is one of the most interesting innovations in the field of artificial intelligence. These are intelligent and autonomous systems that perform complex tasks with little or no human intervention. The agents can learn, adapt to their environment, make decisions, and work as a team to meet complex goals. The slogan is "The future is agentic." And it's important to mention that the insight I'm leaning on are coming from someone I really look up to, named Andrew Ng, a pioneer in AI, scientist, and one of the co-founders of Google Brain. But we have a lot on our plate today, so let's begin. And first off, let's clarify the difference between LLM-based agents and agentic workflows. And Andrew Ng explained this at the AI Ascent conference of the capital fund Sequoia Capital in March this year. I will also leave the link in the description so you can enjoy the full session. So, large language models or LLM-based agents typically generate responses to prompt in a single shot. For example, you might ask an LLM to write an essay and it will produce a complete draft in one go. However, this approach often lacks depth and refinement. This form is also called zero-shot prompting because it tries to hit the basket on the first shot and get a good result without iterations. Now, it turns out that, like humans, language models also struggle to succeed on the first shot to bring the perfect result. Therefore, the OpenAI company created the ChatGPT 3-4 language models in a chat format, which allows us to get more out of the model with the help of additional iteration on the same topic. To give comments, divide the problem into sub-problems, require the model to perform self-reflection, etc. In contrast, agentic workflows involve AI agents that perform tasks iteratively, much like how humans would work on a project in stages. These agents can draft, review, revise, and enhance their outputs in multiple steps, leading to more refined and higher quality results. The iterative process is more collaborative and adaptive, which is crucial in complex fields like cybersecurity. Now, before we dive in even, let's talk about Andrew Ng. He's a renewed figure in artificial intelligence and machine learning. He founded Landing AI and DeepLearning.ai, co-founded Coursera, and is an adjunct professor at Stanford. Andrew co-founded the Google Brain project, which developed large-scale deep learning algorithms and created the famous Google Cat experiment. He also served as a chief scientist at Baidu, building a large AI team. His work democratized education through platforms like Coursera, providing high-quality online courses from top universities to learners worldwide. Now, during the same conference, Andrew Ng presented fascinating research on the performance of language models in coding tasks. His team used a dataset called HumanEval, originally published by OpenAI, which contains 164 small code challenges. For instance, one challenge might be to write a function that sums all the odd numbers that are in even position in a given array. Now, Ng's team demonstrated that using an agent or several agents to tackle these problems iteratively yielded significantly better results than a zero-shot method applied directly to even the most sophisticated models. The first place was won by an agent called Agent Coder, which is actually a coordination of several agents working together iteratively. This model scored 44% higher than ChatGPT 4 in zero-shot mode. This finding illustrates the potential of agentic workflows where AI agents collaborate and iterate on tasks, leading to more refined outcomes compared to the traditional single-shot responses from more advanced methods. This example underscores the power of agentic AI and its potential to revolutionize complex fields like cybersecurity. By enabling AI agents to work together iteratively, we can achieve more robust and effective solutions, whether it's in coding, cybersecurity, or any other complex field. So we now know that agentic AI refers to AI systems that operate autonomously, making decisions and taking actions without human intervention. Now think of it as having a team of highly skilled security experts who never sleep and are always on the lookout for threats. To put it in perspective, consider how a smart home system works. Imagine a smart thermostat that learns your daily routine, adjusts the temperature based on your preferences, and even detects unusual activities like a sudden temperature drop that might indicate a window left open. Similarly, in cybersecurity, agentic AI continuously monitors network traffic, detects anomalies, and responds to threats in real time. So now let's break down how AI agents work within agentic AI using an example of malicious code creation scenario. Now imagine attackers wanting to generate malicious code. They could theoretically use a set of AI agents with distinct roles to automate the process. One team can be architects of the code. These agents define the structure and requirement of the malicious code. They outline what the code needs to achieve, such as stealing data or disrupting services. Second team can be coders. These agents write an actual code based on the architect's specification. They use advanced algorithms to generate code that fulfills the defined requirements. Another team is quality assurance agents, and these agents test the generated code to ensure it works as intended without errors. They simulate different environments to identify and fix bugs. The fourth team can be cybersecurity experts, and these agents evaluate the code from a defensive perspective. They ensure code can bypass security measures and suggest improvements to make it more effective. In an iterative process, these agents work together until the task is completed. The architect set the task, the coders generate the code, the QA agents test and refine it, and the cybersecurity experts enhance its effectiveness. This automated iterative approach allows for continuous improvement and adaptation. So let's see a few examples. The first one is LLM agents can autonomously exploit one-day vulnerabilities. And researchers Richard Feng, Rohan Bindu, Akui Gupta, and Daniel Kang have demonstrated that large language models like GPT-4 can autonomously exploit one-day vulnerabilities. These vulnerabilities are security flaws that become publicly known and exploitable before a fix is available. So in their study, and I will leave the link in the description, the team tested GPT-4 against a dataset of 15 real-world vulnerabilities. GPT-4 successfully exploited 87% of these vulnerabilities, significantly outperforming other models and tools. This capability was achieved using a React framework, allowing the AI to autonomously navigate and exploit security flaws. This research highlights the urgent need for proactive cybersecurity measures, as AI's potential in exploiting vulnerabilities possesses a significant and evolving threat. Regular updates and timely application of security patches are crucial in mitigating these tasks. Another example, this one really excites me, is Project Voyager. And imagine a world where AI agents can continuously explore, learn, and adapt without human intervention. That's exactly what Project Voyager is doing in Minecraft. And researchers from Caltech, Stanford, the University of Texas, and NVIDIA have developed Voyager, the first large language model powered agent designed for lifelong learning in an open-ended environment. And Voyager operates in Minecraft, a game known for its endless possibilities and lack of a predefined end goal. This makes it the perfect playground for testing AI capabilities. Now, Voyager consists of three key components: an automatic curriculum that maximizes exploration, a skill library for storing complex behaviors, and iterative prompting mechanism for improving performance based on feedback. One fascinating scenario unfolded when Voyager's NPCs, which are the players, tasked with building a village, ran out of nearby trees to chop for wood, and instead of getting stuck, these AI-powered NPCs got together to discuss a solution. And they decided to move to a neighboring village, eliminate the population there, and use the wood from their houses to continue their construction. And this decision showcases Voyager's advanced problem-solving and decision-making abilities, even when faced with unexpected challenges. But how does Voyager achieve this? The AI uses GPT-4 to interact with the game environment. It processes feedbacks from its actions, learns from execution errors, and self-verifies its tasks. This iterative learning process allows Voyagers to continuously improve and adapt its strategies. And the implications of this technology are profound, right? In cybersecurity, for instance, AI agents like Voyager can be used to simulate attack, identify vulnerabilities, and develop defense strategies autonomously. And this not only enhances our ability to respond to cyber threat, but also allows us to stay ahead of potential attackers. And the Project Voyager demonstrates the potential of AI in creating autonomous agents capable of lifelong learning and adaptation. Whether it's gaming, robotics, or cybersecurity, the ability of these agents to learn and evolve continuously opens up new possibilities for innovation and problem solving. Now, Andrew Ng's vision for agentic AI is transformative. In his talks and articles, he discusses how AI agents can autonomously perform and refine tasks similar to how humans would iterate and improve their work. This concept is known as agentic workflows. Instead of traditional static AI interactions, agentic workflows involve iterative processes where AI models continuously improve their outputs. And Ng explained four key design patterns for agentic workflows. The first is reflection, and AI models reflect on their own outputs and identify areas for improvement. For instance, an AI that generates code can review it for correctness and efficiency, then refine it based on its self-feedback. The second is planning and multi-agent collaboration, and multiple AI models work together, each specializing in different tasks. For example, one AI could generate code while another reviews and optimizes it. The third is tool use, and AI models use external tools to enhance their capabilities, such as code generation tools or web search tools for additional information. And the last but not least, many-to-many use, combining different AI models, each with a specific speciality, to work collaboratively on complex tasks. So Ng believes that these agentic workflows will significantly enhance the capabilities of AI, moving beyond instant, one-shot results to more redefined iterative processes. This approach promises to unlock the full potential of large language models and AI systems in various applications, including cybersecurity. So to conclude, as we have seen, agentic AI can push the boundaries of what's possible in cybersecurity. The ability of AI agents to continuously learn, adapt, and make decisions autonomously is revolutionizing how we approach cyber defense. However, this also brings us closer to a future where AI might suppress human intelligence in certain areas. It's crucial to develop these technologies responsibly and ensure they are used to benefit society. Thank you for watching. If you found this video informative, please like, comment and subscribe. It will only take you a second. For more insight into the world of AI and cybersecurity, stay safe and stay curious. Thank you very much. Until the next time. Bye.